On Lissajous Figures, downloads for our text chapter F, and let's see what we can find here on the Lissajous Figures. The text has three worked out for us, so let's look at these three and see if we can understand them. First of all, you have a playing field here in our game. This is the oscilloscope that's going to be used in a special way where you send in the signal along the horizontal and one for the vertical, and you get some neat patterns. These are the instructions over here to the left. The instructions, it's important to note that the horizontal axis here is not space as it is over here. See, this is actually space. This is geography. This is time. Like 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. This is your space. In fact, the vertical is used to represent different things in each case. Here, the vertical represents rightness or leftness. Here, the vertical represents upness or downness. North, south. Here, east, west. So here we start neither left nor right. Neither left nor right means along the center line. Here we start neither up nor down, so we start along this horizontal, and where the crosshair, see here's a cross, where they cross, that's where we're going to start. So think of this as the football game having 4 quarters, and the first quarter, the instructions here says, I want you to go from neither left nor right, walk to the right 4 paces, 4 blocks. At the same time, you have to walk up 4 paces. So if you have to go up, let's say 4 kilometers, and you have to go east 4 kilometers, you'll go northeast. You'll go along a slant. So along this slant, we go 4 to the right, and we go 4 up. Now, another way of looking at this is more formal. You can make a coordinate pair for each of these points. In other words, this is 0, 0. This is x in math classes. This is y. So x is 0, y is 0. Up here, x is 4, y is 4. This can help. So in this case, you have x information, and here you have y information. That's the important thing to understand. Here, x is horizontal. Here, y is vertical. Over here, x information is vertical. Y information is vertical. All the information is vertical for the geography. And the horizontal is time sequence. So here, after the first quarter, this says, for the second quarter, come back to the middle, neither left nor right, but come to the left, come back to the left. This says come on back down. So we come back to the center. This says continue to the left, continue going down. So we come down here, and then we go back up. The engineer uses this to measure frequency ratios. We count how many times we hit the ceiling and how many times we hit the right wall. We ignore the left wall and the floor. Here we hit this corner, and that is touching the ceiling and the wall at the same time. So 1 ceiling, 1 wall, and the ratio is 1 to 1. We say the frequencies are equal, and looking at the waveforms, you could say, yep, a wiggle in the same time frame, it's a wiggle. They're the same frequency. If we come down here to the next case, we are looking at an analysis of the same frequency again, wiggle and wiggle, same time frame for the entire cycle. It's just that this has been shifted to the right. But if you look here, 4 blocks of time, 4 blocks of time, and then 4 blocks of time, 4 blocks of time, that gets you your wavelength. You have the same thing here, 4, 4, 4, 4. Remember, this is time, and this is your x or your right-left information, and this is your up-down or your y. You can think of this as negative here, -1, -2, -3, -4, and when your x is negative, you mean head over to the left, head west. When your x is positive, 1, 2, 3, 4, head east. Let's do this one with coordinates. This says x is 0. This says y is negative 4. So if I look for x is 0, that would be here, and y is negative 4, I'm down here. That's where I start. If you then look at this point at the end of this quarter, this says x must be 4, and this says y is 0 for that same corresponding time point in time. So with x being 4 and y being 0, x is 4 here and y is 0. That's the point, so we can connect them. So you can find the points at the beginning and at the end of each of these intervals of time and then draw the lines. If we go to the second quarter, this says come from right to left where we're going to be centered, all right, because neither left nor right. So come to the center line. But how do I go in the vertical? Well, this says here, keep going up. So if I go left and keep going up, I go to second base. This says keep going left, but now come down. So go left and come down. I go to third base, and by this point, the brain kicks in the other side, the artistic, the holistic side, and sees the pattern and gets finished real quick. You hit the ceiling one time, you hit the right wall one time, 1-to-1 ratio, same frequency. Notice that the phase shift has made this into a diamond shape, while before it was a line. It's as if this unfolded, and you can now see a diamond. The last case is to do a comparison with double the frequency. Here I go wiggle, and here I go wiggle, wiggle. So this is 2-to-1. I expect to hit the ceiling twice and hit the wall once, which you can see as the result. That's going to come out that way, and the engineer will conclude that 2 on the vertical compared to 1 on the horizontal ratio is 2-to-1. If the horizontal is 1f, the vertical must be double, 2f. Well, we start here at coordinate x equals 0, y equals 0. You know, it's a nice way to get paper and pencil at, and go ahead and put a parentheses and then put an x and then a comma and then a y and then another parentheses. And they're your coordinates. And each point in this plane field can be represented by a pair of xy coordinates. For example, the center is 0, 0. This is 0 for the y, and for the x it's 4, so that would be 4, 0. So we can do these various ways. Let's do the first one by just visual. We go here from neither right nor left, from neither up nor down, from the center that is. We head 4 to the right, 4 blocks to the right, and we go up, down. So if I go 4 blocks to the right and go up, down, that's the answer. Now you could do that with coordinates. You could say, hey, look at this coordinate. Here is the y is 4, and here the x is 2. So I want 2 for the x, 4 for the y. Well, where is x equal to 2? There it is. And where is y equal to 4? Way up there, and you get the same result. It's always good to know more than one way to solve problems in math and physics. Then here, it says come from way at the right to the neutral, neither left nor right. And when you do that, go down, up. So as we here come to the neutral line for left and right, we go down, up. So that's the second phase. And you could analyze this with the coordinates. You could say, I'm going to start here where x is 4, and then x will be 2, and then x will be 0. And here, see, when I start with x is 4, y is 0, so x is 4, y is 0. And then as x is 2, I come on down here and I see y is negative 4. So when x is 2, 1, 2 along the x, y is negative 4. And I could draw the line. And then here, at the end, y is 0, x is 0, So I come back to the origin. Here this says keep going to the left and go up, down. So if I keep going to the left, I go up, down, and then here the brain kicks in and gives you a nice pretty picture. And we have 2 times at the ceiling, 1 times at the wall, a 2-to-1 frequency ratio when we compare the vertical oscillations to the horizontal.